Okay, assuming that you've logged into Blackboard and have gone into lab modules, we're going to start with Lab 5, Functions and String Input-Output. Now, there's a lot here that we're going to have to do. There's a number of functions that we're going to have to create. And let's see, we've got one initial. Let's see what we're up against here. So that's one program, two programs by looking at another initial. And let's see, wow, 3 programs today. That's a lot to do. So hopefully you've been prepared for this and know what you're doing by reading over sections of the text and online notes that you're going to find under course documents typically. So let's see, in this program you will have more exposure to functions, and we're going to have to use a math function for some of this. Let's get right to the chase here. You're going to learn the difference between scanf and getstring, and basically what we're going to do is write a program that calculates the cubic root. Cubic root means that if you multiply a number by itself 3 times, such as 3 times 3 times 3, that's 27, so the cube root of 27 is 3. So we're going to have an explain function, a get value function, a cubic root function, and a display function. So all the basic 4 function types that we're going to have. Now the explain function, it's going to be void, explain, void, as we'll see, because there's nothing being put in, nothing coming out, it's just going to explain stuff. Now this one, get value, prompts for a floating point number and returns it to main. So because it's getting the inside the function here, it's going to scan something from the keyboard. We don't have to pass anything into the function, but we will indeed be getting something back, and the thing that we're getting back is a float, so it's going to be float, get value, void. This one, cubic root, takes a floating point value from main, so we're going to have to pass it in on the input side here, pass in a floating point value, do a calculation, and return over here a floating point value back. So that means that we're going to have float, cubic root, float, and some variable name here. Now display is going to be called by main to show the original and the cubic root values. So what it's going to do is it's going to take in the original and the cubic root value, but it's going to be void because all of the stuff it's sending isn't going back to a variable, it's going to the screen. So it's going to be void, display, and then float something, comma, float something else. So that's basically how our function prototypes are going to look, and when we get into that, we'll understand that a little better. Now, it shows us basically what we're going to have to do. A programmer's block includes sections and function prototypes. Doesn't really matter what order you do them in. I prefer to do includes and then function prototypes, but that's neither here nor there. And we usually have our main next, and then after that we do our function definition section. To be honest, you can put the function definitions up in this area as well, but I like to keep them after here because I figure that main is the main function and any other functions aren't as important, so I just like to organize them this way. So let's get started, and let's go back here, and we've got our 4 labs from before. So we're going to say File, New, Project, and we're going to say Win32, and again I'm using my F drive, so I'm going to use Lab 5. And again, we're going to create 3 programs under here, and the 3 programs that we're going to create under here are going to be Lab 4A, 4B, 4C, just as we did last week with that. Again, under Application Settings, we're going to choose Empty Project and say Finish. And when all that's done, we're going to start with our basic code as we've done in the last couple of labs. So we're going to right mouse click on Source Files, Add New Item, and we're going to call this Lab 5A. Okay, Lab 5A. And once we've done that, we're going to start typing, and we're going to go Shift Alt Enter to go to full screen mode, and we'll put in our programmer's block. Now as we do this, let's go back and take a look and see if we can figure out what has to go in the programmer's block. The programmer's block is going to be title. This is a program to find the cubic root of a number using functions. So let's put that in. So our title, program to find cubic root of a value using functions. Okay, so that's pretty straightforward. And our name again, student ID number, and PRG155 in your lab section. Today's date happens to be, for me, June 8th, but it's going to be after that for you, for sure, 2009. And description. This is where it's going to get a little bit tricky, and this is why I'm going to help you out with that, because there's a lot to write down here. And let's take a look and see if we can figure out a description based on what we've got here. Now this is where we're going to digress from writing down a description in our programmer's block and our actual explain to user. Explain to user will be different. The details of how it's going to do this is going to be not something that the user needs to understand. For instance, when you turn on your car, you put your key in your ignition, you turn it, it goes on. That's all they need to know. They don't have to know about the starter, the solenoid, how all the things work, but the person that's going to fix your car or design a car needs to know all that, but that's not what the user needs to do. So we're going to put a fairly good description in the programmer's block for programmers, but then the explain to user is going to be a lot more simplified version of that. So let's get started. So the programmer's block is going to say that it's going to, main is going to get a value from the get value function, and then it's going to take the value that it gets from that, pass it into the cubic root function that returns the cubic root, and then it's going to use the display function to show the original number and its cubic root on the screen. So let's see if we can write all that up. Okay, so let's switch back over here and put in description. Okay, main will get a value from the get value function. It will then send this value to the cubic root function. The cubic root function will return its value to main. Main will then send the original value and its cubic root to display. Now, as I said, all of these details are not really essential or even wanted to be known by the user. They don't care about this stuff. This is stuff for a programmer. So the explain to user is going to be different than traditionally what we've done is just copy this down. So we're going to have to make a different explain function, which is fine. So once we've got that done, the next thing we're going to put in is our include section. And if you want to put your function prototypes next, that's fine, but I like doing it this way. So if you want to do it in a slightly different order, that's fine. But we're going to say $ include standard io.h, and it defines for getchar. Well, let's do the most important one: printf, scanf, getchar, putstring, fflush, and $include conio.h defines for the get ch command, and $include standard lib.h, and these have the definitions for the system command. So those are the pretty basic ones we've seen all along. Now our function prototypes, let's take a look at those. And let's get a little bit lazy. Let's switch back over here and see what function prototypes we need. We need explain. So let's control C that. Let's go back over here. Let's put it somewhere. Let's just put a space in here and put a control V in, and that's our explain function. We'll do a little bit more with that in a minute. And so what we're going to go over here is again space, and let's go over, and the next function we got is get value. Let's get these exactly right. Whoops. Let's grab that. get value, paste that in about here, and then we'll put in the actual just full stuff for that in a second. Let's go back here, cubic root, and put that in. And finally our display function, let's go back there, get that. So let's save ourselves a little bit of time with this. And this is the hard part to actually fill in. Now, as I said before, there's nothing coming out of the void, or sorry, out of the explain function, because it's just generating a bunch of stuff on the screen. So since it's sending stuff to the screen and not returning a value back to the variable, the output is void. So that's the output side. It doesn't require any input because it's just a bunch of printf statements, or in this case put string statements, and we'll just put a semicolon there. So that's explaining what's going on there. So this is our explain to user section. Now the get value, if you think about it, it's getting a value and it's returning that value back to main. That's what it says in our description up here. So we're going to be returning a float from our get value, but since it's getting the value not from a variable that's passed into it, right in the actual function get value, it's going to scanf and then throw it back up, then that's going to be void. So let me just move this over, make this a little prettier, put a semicolon here, and this is our get user input part here. And cubic root, what it's going to do, it's going to do a couple things. It's going to return the cubic root of a value, but it has to also take in a number, a cubic root value as well, or the number to find the cubic root of as well. So let's put in a semicolon here. So it needs input and it's going to generate output as well. So this is our calculation part. This is our function that's going to do the calculation. And finally, our display is sending stuff to the screen. It's not putting things into a variable. It's sending stuff to the screen, so that's void. And then we're going to have to put in what it's going to do. It's going to be float x, float y, something like that. It's going to take two values, and we'll put a semicolon here. Let me just move these over a little bit more. So this is our calculation, and finally this is our output section here. So these are how our function prototypes are going to work. Now this is the most critical part here to understand, that nothing in, nothing out, nothing in, because it's getting it from the keyboard, so it's not getting it from something passed in, and it's returning it as a float. Here it's taking in a float, doing a calculation, returning a float. Here it's taking in two floats and just printing them on the screen, so nothing coming back. Now let's take a look, and you can see here it's got function prototypes, which we've done, and include section. Next is main, and then function definition. So let's get that happening. So let's go back, and integer main void. Now why is it void? And in this case we don't put a semicolon because this is like a function definition for main. This is telling what the actual code is in here, and it's returning an integer. Now where is it returning an integer to? Well, it's returning it to the operating system, and we'll talk more about that in an upcoming lab. And we'll introduce a return 0 for main today, just to show that it will be returning 0 back to main. And that's what we should have been doing actually all along. So let's take a look. In main we're going to have a variable, declarations, and we're going to have an explain to user. We're going to have a get user input section. We're going to have a calculation section, and we're also going to have an output section. And that's basically the framework for our main. And then we have our function definition section. Now our function definition section is basically just going to be these copied down. Now what we're going to do is copy, but not the semicolon, because function definitions like main are like main. They don't have a semicolon as part of the description. So we're just going to put in a open and close bracket for now, brace bracket. And once we've done that, we'll go up here and grab the next one. And it doesn't matter which order you put these in, as long as they're just put in somewhere. Doesn't matter what the order. So we'll just put this in an open bracket and a closed brace bracket. And let's see, let's get cubic root. So as we saw before when we're doing this, we don't have to flesh in code to have these things sort of work. It means nothing's really going to happen, but the thing is that with empty function definitions, it's just going to hit the bracket and return. We have to have three parts, as you may have remembered. We have to have a function prototype, a function definition, and the last thing, and this is what we put typically in main and can be in other places as well, as we'll see, but we have to tie these in. We have to put in a function call in here, and that's where these function calls are going to go. So we've got our basic framework to work in, and let's go back again and take a look and see exactly what it is we're supposed to do. And it says write a program to calculate the floating point number, explains to the user. So let's work on that first. There's no variable declarations required for explain, but let's see if we can come up with a simpler value, or version, sorry, simple version of the explain to user. So let's take a look, and this is where we're actually going to write our code. So as before, we're going to put system, clear screen, and now we want to explain it in terms of what the user needs to see. Now if you think about it, the user is just going to be prompted for a value to find the cubic root of, and then they're going to be given, here's the cubic root. So let's see if we can write that into simple English. You will be asked to input a value to find the cubic. Now, here's something we can do. Sorry, quote, bracket, semicolon. Root, put string, cubic root of. Then the program will show you the original value and its cubic root. Now this is a very simple description of what your program is going to do, and this is all really the user needs. Now if we want to, we've already written all the code for that, but if we were to run the program now, let's just hit F5 and see what happens. Nothing's going to happen. It's going to compile. If there's any errors, it'll show us the errors. There were build errors, and let's see, what does it say? It says get value must return a value. So there are some problems with the function. So when we're returning stuff, that's going to be an issue. And it tells us that cubic root and get value must return a value, and that's why it sort of isn't working to this point. So get value. So we're going to have to write these two because in the past we just had voids, if you remember, but it's a little fussy about making sure that we return stuff. So let's see how we first of all tie this in. For the explain to user, all we have to do to tie this in is we don't put void or void. We just grab our explain function like so, Control C. Let's just paste it in up here, and what we do is we just put brackets. Now this is how you use it as a function call, and the function call is to explain to you, or is explain to user, but there's nothing else. There's no variable here, and there's no variable in here. The brackets are empty, and that's what void explain. Void means no variable, no variables in here, to the left or inside the brackets. So we've got that. That should be okay. Get user input. Well, let's see how we're going to deal with that. Let's see, how do we write the get value routine? Well, let's go down here, and there's a couple ways to do this actually. I'm going to do something strange. I'm going to put the printf, the actual prompt, and this is a very good way to do this. Printf \n input a number to find cubic root of. Now I'm going to prompt here, but I'm not going to do the scanf here. I'm going to then do the scanf actually in the get value routine. So the scanf is going to be down here, but before we do the scanf, one of the things we should always do is Fflush standard in, as we've seen before, then scanf, and here's where it gets a little interesting. Scanf, %f, because it's a float, comma, ampersand, and now we have to come up with a variable name. And if we're doing a variable, we're not going to put our variable up here. We're going to, since we're scanning down here, we're going to have to put our variable there. Now I'm going to call it Fred, and once we scan Fred, we're just going to return Fred. But to make sure this is going to work, because these names aren't all that important, but we're going to have to put in here a variable declaration for this actual function definition. So what we're going to have to do is say float Fred, and therefore we have everything that we need. We're going to scan Fred, scan to Fred, return Fred. Everything's pretty much done in here. To tie it in, though, what you're going to have to do up here is we're going to have a variable that's in main that's going to grab it. Now I'm going to say float, and if you think what we need here, we need a variable to grab what comes out of the get user input function, and we're going to have another variable to hold the value that's going to come back from the calculation function. So I'm going to call it, I don't know, Bob and Sally. Doesn't matter what you call them, I'm just calling them arbitrarily this. So what we have here is Fred is going to have a value in it, and it's going to pass back, and this is going to be a little strange at first, but what we're going to say is Bob is going to get the output of the get value function. And notice that, why do we write it this way? Because we look down here, get value, nothing in, so we're not sending anything in from here. We're getting something from the keyboard down here, and this is the way it works. It's like a scaffolding. If you're on one lever, you say, okay, send me up something there, Fred. So they scan something into the Fred bucket, grab something from the keyboard, put it into the Fred bucket, and the Fred bucket gets its contents tossed up as a float, and the thing that catches it up here is Bob. Now, these are different buckets, but the buckets aren't being passed, it's just the value in the bucket. So if I scan a 5, the 5 gets returned, a 5 as a float, and Bob, being a float, grabs the 5. So it's bucket to bucket. So that's a very strange thing. That's why I'm not using the same variables. I'm using Fred down here, I'm using Bob up here for a very good reason, to show you that these are just buckets, or they're just containers, and they don't have to have the same name. Sometimes books show them as the same name, and that gets a little bit confusing, but I'll show you that indeed this will work. So at this point, Bob is going to have the value. Now what we need to do now is, once we've got that, is to perform a calculation with that. Where are we putting the output of our calculation? Well, we're putting it in Sally. So let's bring Sally down here into the picture. Let's put Sally is going to get the output of, strangely enough, the cubic root function. So let's grab Control C that, because we're lazy. Is going to get the output of the cubic root function, but we have to put in a value for the cubic root function. And notice it says down here, it's hard to see. Let's bring up the magnifier here, if I can do that. No, it's not going to work. Okay, sorry about that. But instead of putting in the value down here of num, that's not what we're going to do, because these are just buckets. And the concept here is that we've got, from the keyboard, we got a value, put it into Bob, and that's the value we want to find the cubic root of. So what we're going to do is take the value that came back and feed that in as the input to this function. This is really strange. Keyboard goes into Bob. So if you type a 5, 5 is in Bob. Take what's in Bob, which is 5, find the cubic root of it, put it into Sally. Now that's a little bit better to understand, but you have to have a consistency going up here in the main. So keyboard, you type a 5, it goes into Bob, then you take Bob as the output, feed it in as the input to the cubic root function, and find the cubic root of 5, and that goes into Sally, and then we can generate output from that. Now let's take a look at what we have to do, because even though we've got an idea of how the information is going to move around here, the thing is we haven't yet defined the cubic root function. Now one of the things that you're going to have to look up or understand is that there is a power function. And if you say power, of num, which is our number that came in. One of the things you're going to have once you start defining this is if you've got this defined as num, you cannot say float num here. It's not going to accept it. It shouldn't, because you've already got num as a bucket that's catching something, and then what do you do with it? Now, you'll see in class, if you say num, its power of num to which power is the 1.0 over 3.0. In other words, if you take any number and say 5, 5 to the 1/3 is the cubic root of 5. 6, 6 to the 1/3 is the cubic root of that. Now, we could set up a variable to say Jane or something, and Jane equals power of this, and then return Jane. What I'm going to do is, I'm lazy, so I'm just going to say return bracket, and then put another bracket here at the end. And what it's going to do is that if I type in a 5, it's going to find 5 to the 1/3 power and return that as a float back up to, strangely enough up here, Sally. And that should work. So just realize that this, whatever you've got coming in, now I'm going to do something. I'm just going to, so we can see this a little better, I'm going to Control X, move this function up near the top of the function definition so we can see what's going on, Control V it back in. I just want to show you the interaction. So we got something from the keyboard, and it went into Bob. Then we took the output Bob, fed it into the input here, and then we pass it in. So if this is a 5, as I said before, you're going to have a 5 being passed down. So whatever's in here, that's a bucket. It drops the 5. The num bucket catches it, and whatever you want to do with that, that's 5 to the 1/3 power. It's returning that as a float back up to Sally. So whatever the cube root of 5 is, it's going to be back here. Now let's worry about our output. And how do we do the output? Well, we're using a function called display, so we're going to say display. Notice, remember, if we look back, display up here is void, so that's why there's no variable off to the left. And the thing that we're going to display is we're going to display Bob, which is our original number, and Sally. So what it's going to do is whatever is in Bob, so we type 5 into Bob. So Bob is 5, it takes the 5, finds the cubic root, puts it into Sally. So this is 5, and then the cube root of 5 are going to be displayed. Now let's take a look, and let's grab the display routine, and let's bring it up to the top. Let's just Control X and bring it up here so you can see it a little better. And if we put it in here, what we want to do, and it's a very simple thing, is we want to print a printf, and we already have X and Y coming in. Now notice, if you've got 5 here, that's this bucket, and another bucket, this 5 goes into the X bucket, and wherever the cube root of 5 is, goes into the Y bucket. It's very simple. 2 buckets, doesn't matter what the name is. Hey, I'm sending you down a 5. Okay, X says, I'll grab it. There it is. And what do we do with it? So you're going to say \n, original number was %.1f, cubic root is %.1f, quote, comma, x, comma, y. And that should pretty much do it, semicolon. So if I type in 5, let's use a simpler number, 27, and that goes into Bob. So Bob is now 27. I take the 27, find the cubic root of 27, which is 3. Sally is 3. So I'm going to pass the 27 and the 3. So the 27 comes in as x. So wherever x is, it substitutes 27. So 27, original number is 27, and Sally is 3. And wherever y is, it's going to take the y and say that's that. Now let's run this up and see if I've made any massive blunders. Whoops, we do have a problem. And what does it say? Power. Yeah, I forgot about that. Now one of the things that we'll find, and let's take a look at this up at the top, look at our includes. Do we see anything here that has power as part of it? No, because one of the things, and it even mentioned this in the lab, let's take a look, power function, and it says we have to include math.h. Now being lazy, boom, let's grab that and let's go back. I'm going to put in, enter, Control V, include math.h. Now obviously it has the defines for power, which we're going to use as a function, but it also has sine, cos, tan, and square root. These are the definitions it has. Now of all these, we're just going to use the power today. Now let's punch it up and see if it's going to work. And there's more build errors. Let's see what's going on. Okay, let's see what is really going on. Let's see what it says. We'll bring in our magnifier here and see if we can read this. Lab 5A, blah, blah, blah. Error. Put identifier not found. Oops, put. Oh my goodness. So, let's take a look and see where we've got our put. So, let's see. Now it even says what line it says on line 42. So if we just double click on that, it takes us to line, and what did we forget? Yes indeed, we forgot to put string. Okay, now that we've got that solved, let's take a look here, and we seem to be having another problem. And the problem is, let's take a look with our magnifier down here. And it says power overloads F7, and it says there's a number of possible conversions long, and actually we're using this one, float, power, float, float, but unfortunately our compiler isn't that smart. So let's go back and take a look and see what's really going on. What it means is that when you're using the power function itself, let me bring this up. When you're using the power function itself, you cannot perform a calculation that generates a float as part of it. It has to have a real float number in there. It cannot do the calculation. So let's see how we can fix that. And we're going to have to, in here, have a float variable. I can call it anything. This is a local variable. Float x, and I'm just going to say x equals 1.0 over 3.0. And if you remember, if we don't make one of these a float, as we've seen in a previous assignment, then, or both of them, then it's going to be an integer. So it's going to give us the same calculation, but now if we replace this with just the x, what we're going to find is that it's done the calculation, and it doesn't have to do the calculation. You're supposed to pass in a float. You can't pass in a calculation to be performed in here. And if we punch it up this time, indeed everything says linking, everything's fine, and we're going to get our output screen, and this is what we want. So 27, enter. The cubic original number was 27.0. The cubic root is this. And as we've done before, let's right mouse click, edit, mark, and grab all of this stuff. Right mouse click out here, and at the very bottom of our program, and this is a very long program, and it's taken a long time to put it all together, and I do apologize for that. But let's put in our output so we have a complete output of what our program does, and that we have a permanent record of it. Okay, so that's this part done, and make sure you print this out. Make sure you read over carefully your notes. At some point I'm going to be going through a trace and show you step by step how the variables get moved around, but for now let's just get through this lab. So let's go back from full screen. Let's make sure we save file and save lab 5A, so we can now bring up. Now before we do anything, as we've done in the past, let's grab all of this stuff here, and we won't need the math.h in the next lab, so let's just control C that, and then we can right mouse click and remove, but don't delete, remove this, so we can then start up by adding a new item and adding lab 5B. And once we've got that, we'll control V this in, whoops, control V this in, and then continue on. And let's take a look at what the next program is that we have to write. Okay, if we take a look at the second problem, it's not that difficult. It's just a matter of copying and pasting. Now we've already got the include section in here, so all we need is main, and don't forget we're going to have to change main because it has to be a little different than just main bracket bracket. Let's control C. Let's go back over here and paste that in. Control V, and as I said, let's change this. Let's go full screen. Shift Alt Enter, and let's bring this over first, and let's go back from full screen, sorry, and flip the indent on that and go back to full screen. And once we've done that, we should change this, as I said, to integer, int main, and then inside the brackets put void. Once we've done that, all we have to do is clean up these quotes, and what this is going to do is it's going to show us what the difference is between using a scanf with a string. Now we haven't worked with strings before. Actually, strings are pretty much covered in the next programming course, PRG 255. But we're going to just play a little bit with them today and get the idea of what the difference is between this new command. We've used putString, PUTS. Now here's one that's getString, to get a string from the keyboard. Now to get a string, some of the things we have to do is define a character array. This is an array structure, name of 80. It's going to have 80 slots in it because there's 80 characters across our screen here. So it can take up to 80 characters, and each one is going to have its own little place. So a character, an array of characters, is really a string, a bunch of characters together. So when we say %s, what that means is we're scanning a string of characters, up to 80 in this case. And we're using scanf, and then we're going to be using getString. So right now here's scanf, here's getString, and all we have to really do is illustrate by running it and describing what is the differences between these two. So let's run it up and just see. And building and so forth, and whoops, what happened here? We have an undeclared identifier enter. Let's see where that is. On line, it's all on line 22. Oh, what did we forget to do, or what did I forget to do? I forgot to put in and change the quotes. Isn't that clever? If we just click on where it says the error is, that it fixes, or at least takes us where we can fix it. So let's run it up now, and it's going to link this time and do everything. And when it's finished, let's see what it's going to do. And what I'm going to do is I'm going to type in not just first and last name as it suggests in here, but I'm going to say Dave Ross is very tired. In other words, I can type in a sentence, and let's just see what happens. And it just printing out the Dave. Now let's take a look at your code, and now here's a really slick thing that you may not have thought about. Mark. Now I'm not going to mark the whole thing. I'm just going to mark what I typed in because I'm too lazy to type this in again. I'm going to right mouse click over here, and it's waiting for the input again. So I'm going to say edit and paste, and there, look at that, and I hit enter. Now there's the two things. This is a scanf, which only scans up to the first space, leaving everything else in the buffer, whereas the getString allows you to type in everything and it gets everything. Whether we have just 2 names or 20 names or whatever, it's going to allow us. getString gets everything from the buffer. Scanf only gets up to the first space, leaving things in the buffer. And if we happen to look back here, you'll notice that's why we've got this Fflush here. Because if we don't do the Fflush, the space and all the other stuff is going to be then passed on. And that's one of the things it's going to ask later. But for now, let's just see what it says here and how we actually enter the right answer here. What is the difference between scanf and getString? What you're going to write in here is scanf only gets up to the first space in a string, leaving everything else in the buffer. Scanf just gets up to the first space in the string from the keyboard buffer, leaving all the other stuff, including that space and the enter key at the end, in the buffer. What does getString do? getString gets everything from the keyboard buffer. getString gets everything from the keyboard buffer. Now it says describe what happens when you comment out the Fflush line. Well, let's take a look at doing that. Let's just switch over here. Let's comment out this Fflush, and let's run it up again. And what's going to happen this time is kind of interesting. Here we go. And I'm just going to be lazy again. I'm going to edit and paste that again. And so if I Fflush, then it gets rid of this, and then the getString gets all of it. But notice this time the getString didn't even wait for me to type something in. It grabbed what was in the buffer. And what was in the buffer? Well, let me just edit and I'll show you. I'm just going to mark it. It actually had all of this sitting in the buffer. And getString grabs what's in the buffer, or if you flush the buffer, it gets new stuff, but it didn't get the new stuff. This is what it did, and this is exactly what getString did. It got everything from the keyboard buffer. So what it's looking for here is, when we look at the question, it says describe what happens when you take that out. The last name or everything else after the space and everything else on the line is passed to the getString function. So everything, what happens when you comment out this, because you've scanf'd, the space and all other stuff that's left, including your last name and anything else, is picked up by getString, and that's really what it's looking for there. Now that's our second program, and we have to write a third program. Now that was just a copy and paste, so it took no time at all. But this one, it says, now you can start to develop a program with main that has two functions. You're going, oh my God, when is this lab going to end? And you're saying to yourself, it's going to take forever, but it's not that bad, because what are we doing here? We're writing a get full name thing that basically does what we just did in this program using the get string, and that's what we're going to do next. So let's try that. What we're going to do, since we've already saved this, if you haven't saved it, save it again. But what we can do is say file, file, save lab5b cpp as, and what we want to do is we want to make a new file from this. What we're going to do is make this file lab5c, and we have a number of extensions, and we're going to put in .cpp. And what we're going to do is, now we already have another file that we've created which is identical to this. This allows us to keep this one in its original state, but we're also going to now remove this because we made a copy, and we're going to say file, add, existing item, lab5c. So when we save it, everything is in here. It's exactly what we had before, but we're going to work with this. So we're going to do Shift Alt Enter. Let's go full screen. So we've got most of what we need already in here. Now the first thing that we have to do, we've got all this program defined cubic root. Well, we actually should have changed that, but I'm not that fussy about that for the second one, but we should change it for here, what it's going to do. But if you think about it, we're going to system clear screen, we're going to enter your full name, but what we're going to get rid of here is the scanf part here. Why? Because we found that scanf wasn't that great for scanning strings. And we'll get rid of the thing where it says re-enter, because we want to say it to enter our name. And basically this is what we're going to do, and this is going to be get full name. Clear the screen, enter your full name, and actually we don't really, we can put Fflush before we get string. It's not going to do any damage. And then we're going to say print string your name is. So this is basically the essence of our code. Now let's go back and see what it was we were supposed to do. It says get full name, and let's see what it says. No input parameters, excuse me, and no return. So that means void get full name void. So let's, because we're lazy, let's grab this get full name. So we're going to make this into a function. So after our include section here, we're going to go in here and put in our function prototypes. And we'll say void get full name, and in the brackets we're going to type void, and over here semicolon. Now we're also going to need a function definition for this as well. So to do the function definition, we're just going to grab this, Control C, and paste it down here. But we'll put in a title first. We're going to put in function definitions, and Control V that in, and put in our brackets of for our code. Now if you think about it, most of our code that we need is here, and practically all except to get ch. So let's grab all of this, and let's Control X to cut, and then just go down here and paste all this stuff in. So right now we've got everything we need to do the get full name function. Now to check it out, we can just grab this and put back up in here, okay, a function call. So we got a function prototype, and all we need is brackets here, semicolon, and we've got everything we need. We have our function prototype, our function definition, our function call. Let's see if that works. And it's building, and it's doing its thing, it's linking, and maybe, I wonder if it's going to remember that stuff from before. Right mouse click, edit, paste. Nope, it's not going to remember that. So let's write in something else. Let's say Dave Ross, whoops, can't even spell my own name. Dave Ross is very tired. And it does exactly that. It asks you for your name, and it says your name is this. So that works perfectly fine. So we've got this function, it's already tied in. All we had to do is take the code that was here and move it down here, and put in a function call to tie it in. So that was pretty slick. So that didn't take very long at all. Now next thing we need to do is have a function that says get one initial. What does it do? It asks the user to input one character of your initial and returns it to main. And to get two initials, you're going to have to call it up twice. Not write two functions, just use the same function and call it twice. Notice it has no input parameters. Let's see, why does it have no, got that, has no input parameters but has a return value. And if you think about what we did in that very first program, this is really just a scan and return from the function with nothing being put in. So it's very, very similar to what that was. So let's go and get started on that part. So it's going to be void. Nope, it's not void. What is it? Almost gotcha. It says has a return value of type char. So it's returning a char. So we're going to have to put in char space because it's returning a character. And let's go over here and what's name? Get full or get one initial. Control C because we're lazy. Control V and void because it's getting our character, strangely enough, from the keyboard. So what we can do is we can turn this into a function definition by Control C, and it doesn't matter the order of these. So let's do Control V, enter, bracket, and bracket. And what we're really doing here is we're going to have to define a char. So we're going to have to say char initial or something, doesn't matter what we call it. And all we're going to do is basically, and I'm going to just basically Fflush standard in Fflush keyboard buffer, and what we're going to do after that is scanf %C for character and ampersand, and I'm lazy so I'm just going to grab the word initial, Control V, and put that in, and the only thing left to do is return Control V initial. There we go. So that's our get one initial function. Now what we're going to do up here, we've done the get full name, that's our function call. We're going to say is printf after this \n input first initial. So we're going to do our prompting, strangely enough, in main, and now we're going to have a couple variables in main. I'm going to call this char first for our first initial and second for our second initial. And what we're going to do down here is please input your first initial. So first, Control C, first, let's tab that over, gets the output of the get one initial variable, or function rather. So if I do that, it's whatever is scanned from the keyboard here is going to be passed back and is going to be in first. Now we're lazy, so let's, because we're doing this twice, Control C, Control V, Control V, input your word second initial, and we're going to call this second, so we're going to Control C and put this in. So first, our variable first is going to get our first initial, second is going to use the get one initial to get it, and if you think about it, every time it goes into this, it's just going to grab something, put it in the initial bucket, toss it as a char to first in the first case, then when it's called up again, it's going to go in here and scan again something from the keyboard, another character, return it as a char to our second char variable. Now the only thing that's left to do, let's go back over here and take a look. It's going to say your initials are AB. So that's our output, and I'm lazy. So let's grab that. And that's the last thing we have to do in main. Printf \n Control V, your initials are, and it's going to be first dot, or sorry, %C dot %C dot, quote, comma first, comma second. And you're asking yourself, well, why is it %C dot and %C dot? Well, if I type an A and a B, this is going to be A dot B dot. So we have to physically put the dots in. Let's run this up and see if we've got any errors or whether this is going to work. And blah, 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 blah. Linking. Something may be unsafe. Oh my goodness. And here we go. So it's going to say, please input your full name. So I'm going to say Dave Ross is very tired because it's been a long time going. It says that again. Put in your first name D, put in your second initial R. Your initials are D period R period. So this indeed does work. And before we finish, edit, mark, grab all this stuff, right mouse click, enter, and we still have some cleanup stuff to do to get full marks for this. Let's go down here because there's a lot in this program. Even though it's not that long a program, we didn't take a lot of time to write it. Let's put all of our stuff in here, start out, so you can start slash, but we should go up here and say what this program is. To find not the cubic root, but what is this program supposed to do? Let's slide back here. Let's do Shift Alt Enter. Program to print out your full, or to get and print out, sorry, to get and print out your full name and initials. And how does this do this? This program will use the Control V, get full name function to get and print your full name. Then it will use the, oh, I love cutting and pasting, Control V, get one initial function to get your initials. And that's about it. And once we've done this, you should go back from full screen mode, save it, thank God, we're practically done, save as Lab 5C, and we're ready and finished this particular lab. It's been a long lab, but hopefully you've learned a lot from it. See you next time.